All right, this is going to be a lesson on square roots and cube roots. So we're going to go through what the definition of all of these and how to actually calculate them. Right in the beginning, I have a couple definitions that I just put there. We're going to be going through these throughout the lesson, so I'm not going to be going through these now, but you can refer back to these at any time. All right, first thing we're going to talk about is perfect squares. So in the diagrams, you see there are 3 squares that are shaded. Okay, we have a 2 by 2 square. If you multiply, we're just talking about the area, so the area of that square would be 4. This is a 3 by 3, so the length of each side is 3. So when you take the area of that, you get 9. And this is a 4 by 4, so the area of that is 16. So are the shaded portions squares? Well, by definition, a square has same sides that are all equal. So these are all equal sides. They're 2 by 2, 3 by 3, or 4 by 4. So yes, these are all squares. All right, so y can say that all sides are equal. That's how we know that the shape is a square. All right, so this is the start of what's called perfect squares, okay? So the area that I circled up above, 4, 9, 16, those are called perfect squares. So 4 is a perfect square, and that's because you can get it from multiplying 2 by 2 to give you 4. 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square because 4 times 4 is 16. So perfect squares are numbers that you can multiply any number times itself to give you that number. That number would be called a perfect square. So let's list all of the perfect squares. Well, 1 times 1 is 1. So 1 would be a perfect square. 2 times 2 is 4. Remember, squaring it is just multiplying it by itself. So 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. Perfect square. 4 squared is 16. Perfect square. 5 squared is 25. So all of the numbers that I'm writing in purple are your perfect squares. 6 squared is 36. 7 squared, 49. All perfect squares. And you can keep going. 8 squared is 64. 9 squared, 81. 10 squared, 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared, 196. And 15 squared is 225. Now you're wondering, how did I go so fast? How did I know that? Those are the 15 that you should memorize. You should have those memorized by the time we're done with this unit. Now, 16 squared, I don't know off the top of my head. You can do this in your calculator. There's a squared button in your calculator. Or you could just multiply 16 times 16. So I just did that in the calculator. I got 256. So 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is going to give us 400. So those are perfect squares all the way up to 400. Okay, so if it's not in the list that we just created, then it's not a perfect square. So there's no number that you can multiply by itself to give you 5. There's no number you can multiply by itself to give you 10. So those are not perfect squares. Now, let's reverse this idea and let's talk about square roots. Okay, so a square root of a number is one of its 2 factors. So factors going back to 6th grade, those are numbers that can go evenly into a certain number. So they divide evenly into it. So if we're talking about 16, we have 16 can be broken into 4 times 4. There's other factors, but I just want the number times itself. So 4 is the square root of 16. It's whatever number times itself gives you 16. So the way that it's notated, you could see this here in this crazy bubble here. The square root symbol kind of looks like a division symbol right here. Okay, it kind of goes like that. I'm going to get rid of that because then you can't see it. that's the number under the symbol is the one that you're taking the square root of. So whatever number times itself gives you 16 is your answer. So this would be 4. Now, technically, there are actually 2 answers to this because you could also take -4 and multiply it by itself. -4 times -4, they're both the same sign. So you also get 16. So not only could your answer be 4, but the square root of 16 can also be -4. Okay, it can be either one. Most of the time, we're going to be just dealing with the positive numbers, but I know that some practice problems will have you do both. All right, so the symbol that we just talked about is called a radical sign. We say it's called the square root of. That's used to show the number's square root, but it's actually called a radical sign. All right, so let's do some practice here. So the square root of 4 is 2. Why? Because 2 times 2 gives us 4. 2 is your answer, and you multiply it by itself, you get the number underneath the radical symbol, which is 4. So the square root of 9 is 3. Well, why? 3 times 3 is 9. So the square root of 16 is 4. Why? 4 times 4 gives us 16. So do you see the pattern? Square root of 25 is 5 because 5 times 5 is 25. The square root of 100 is 10 because 10 times 10 gives us 100. So that's how we get those answers. So let's do some more practice and find the square root of each number. So square root of 81. So it's time to think, what times itself gives you 81? Well, now, if you're saying 9, that is correct. Now, I just want you to be aware that most of the time we're just finding the positive, but sometimes it could be negative. Now, the symbol that we use for both, it's a plus sign on top of a minus sign. So we could say that it's a positive 9 or a negative 9. We say that as plus or minus 9. Now, what number times itself is going to give us 225? So what number times itself is going to give us 225? Okay, so if you're thinking 15, you're correct. So we're going to write it as you could have a plus 15 or a minus 15. What number times itself gives you 4? Well, you could have a positive or a negative 2 because 2 times 2 gives us 4. Now keep going. What is the square root of 196? Well, you could have a positive or a negative 14. 14 times 14 is 196. All right, how about square root of 121? Well, you could have a plus or a minus 11. 11 times 11 is 121. Now 36, you could have a positive or negative 6 because 6 times 6 is 36. What about square root of 49? Well, you could have plus or minus 7. 7 times 7 is 49. Square root of 16 is plus or minus 4 because 4 times 4 is 16. And the square root of 64 is plus or minus 8 because 8 times 8 is 64. Now, hopefully you're getting the hang of this by now, but I just wanted to create this chart with you because I think that it kind of makes sense when you put it all together in one space. So we're going to talk about the perfect squares, kind of putting it with the square root symbol. So 1 squared, we said was 1. Well, if you take the square root of 1, you get 1 because 1 times 1 is 1. Now watch the pattern here. 2 squared is 4. Well, if I take the square root of 4, I get 2. So you see the pattern. These are my perfect squares. If I put them underneath this radical symbol, you get the number you started with. 3 squared is 9. So if I take the square root of 9, I get 3. 4 squared is 16. If I take the square root of 16, I get 4. 5 squared is 25. If I take the square root of 25, I get 5. I want you to pause the video and I want you to finish the rest of this chart. And then when you're done, just hit play or fast forward over me doing the work and you can just make sure your answers are correct. I'm going to go kind of quickly. I'm not going to speak through this. You can just kind of make sure that your answers are good after you've done it on your own. All right, go ahead. All right, so there's our whole chart, and you can kind of see the pattern there. Okay, perfect squares and square roots kind of go together. So if you know one, you should know the other. Now, I talked about some of those numbers that are not perfect squares, okay? If you take the square root of one of those numbers, you are going to get an irrational number, a number that is not going to be a nice integer, whole number. So square root of 5, we just talked about that. Look at this number. When you take the square root of 5, it's this long decimal. Square root of 23, same thing, long decimal. Now, there is a way to do this in the calculator, by the way. If you want to take the square root of a number, you can enter it into the calculator if you're not sure if it's a square or a perfect square or not. There is a square root symbol right above the 7 if you have the calculators that we use in class. You're going to hit that first, and then you're going to type in whatever number you have. So you can, and that will give you what is right here. So I'm just going to write use calculator. Whenever you have something that's not a perfect square, you're going to use the square root symbol, and then you're going to type in whatever number you have. Now, if you're using another calculator, sometimes you have to type the number first and then hit the square root symbol. So it depends on what calculator you have. The ones from school, you have to hit the square root symbol first. All right, so which is not a perfect square? So we're going to go through the first one, and then you can do the rest on your own, but not a perfect square. Remember, a perfect square has a number that you can multiply by itself to get that number. So 1, you can break down into 1 times 1. 4 breaks down into 2 times 2. So those are perfect squares. 9 breaks down into 3 times 3. So the only thing that is not a perfect square is the 5, because there's no number that you can multiply by itself to give you that number. So go ahead and do the rest of them. You can fast forward in my video if you'd like. So 16 breaks down into 4 times 4. 25 breaks down into 5 times 5. 36 breaks down into 6 times 6. So the only one that is not a perfect square is 23. All right, how about the next one? 49 breaks down into 7 times 7. 64 breaks down into 8 times 8. 9 times 9 is 81, so the only one that is not a perfect square is the 66. All right, last set. 100 breaks down into 10 times 10. 121 is 11 times 11, and 144 is 12 times 12. So the only one that's not a perfect square is 108. So why do we just do that? Because those numbers that we just circled are going to be the ones that you're going to have to put in the calculator. They're going to be irrational. They're going to have a really, really long decimal to it if you take the square root of them. So let's talk about that a little bit more. Irrational square roots always fall between the square roots of perfect squares that they are between. So that square root of 5, now if you notice here, these are all your perfect squares right here. Okay, so 1, 4, 9, 16, 25, all perfect squares. If I take the square root of 5, it is going to fall in between the square root. No, it's not. Come on, Mrs. Slack. What's going on here? It's going to fall in between the square root of 4 and 9 because 5 is between 4 and 9. Okay, so that answer will be between square root of 4 and square root of 5. Well, we already know what the square root of 4 is. Square root of 4 is 2, right? Because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. Well, look up above. What did it say the square root of 5 was? 2.2. Well, if it's 2.2, come on. If it's 2.2, isn't 2.2 between 2 and 3? It is. So let's take a further look at how to actually do that, okay? So let's take a look at the square root of 7, okay? So we want to know what two whole numbers that falls between. So we're going to say the square root of 7 is between what two perfect squares? So what square is just smaller than 7 and what perfect square is just larger than 7? Now you can look at your lists and your boxes that we have just created, or you can look at the one right above here because these are all perfect squares. So 7 again is between 4 and 9. So 7 falls between 4 and 9. Well, it's going to fall between the square root of each of those. Well, the square root of 4 we just said was 2. The square root of 9 is 3. So that means that that square root of 7 is going to be somewhere between 2 and 3. Now, 7 is actually closer to 9, so we know that it's actually going to be closer to 3 because 7 is closer to 9. So we don't have to know the exact number, but we know that it's going to be somewhere between 2 and 3. Now let's check that out in our calculator. Pick up your calculator and actually hit square root of 7. You're going to see that the answer that we get, and I'm just going to write this down, is 2.645751311. So that's going to be closer to 3 because it's over 2.5. Let's just practice that one more time. Okay, so square root of 30 this time we're talking about. So the square root of 30. Now what two perfect squares is 30 between? The smaller one is 25, so it's going to be between the square root of 25. And the bigger one, what's after 25? It would be 36. Square root of 25 is 5. Square root of 36 is 6. So that means that the square root of 30 is going to be between 5 and 6. Now 30 is really close to the middle. It looks like it's just slightly closer to 25, so that means the answer is going to be closer to 5. So let's actually calculate that in our calculator. So the square root of 30, I'm actually going to punch that in. And look at that, 5.477225575. So it is slightly, that 4 tells us it's just closer to 5, barely. All right, again, I want to make sure that you know you can do this in the calculator. So let's just go through and practice a little bit more. So the square root of 89, okay, you can type that into the calculator. You're going to get 9.433981132. Now, how do you know that that's not going to be a nice, pretty number? Because 89 is not a perfect square, okay? 81 is a perfect square, 100 is a perfect square, but not 89. Same thing with 10. I'm going to do the square root of 10. Okay, that gives us 3.16227766. Again, not a perfect square, so I just do that in the calculator. All right, that's called square roots. Now let's talk about cubed roots. Okay, cubed roots are going to be multiplying it by itself 3 times. So the cube root of 27 is 3 because 3 times 3 times 3 is 27. Cube root of 100 is 10 because 10 times 10 times 10 is 10,000. Oh, that doesn't even match up. I think I missed a 0 in there. So I think that's the cubed root of, let me make sure. Nope, typos here. It should be 1,000. All right, so what is the cube root of 8? Okay, now, cubed root of 8 is what? What times what times what gives you 8? Okay, if you're saying 2, you are correct. 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. Now, we don't have to write that every single time. There is a symbol, and here's that symbol. It's got a little 3 with the square root symbol. That's called a cubed root. So how we would really write that is the cubed root of 8 is 2. So that's how you would write it. So again, I'm going to give you this chart because you're going to see a connection between them, okay? So if I'm taking 1 cubed, and to do this in the calculator, you actually have to hit the little caret symbol to give you an exponent. So you're going to type 1 with the arrow pointing up. Then you can type your exponent of 3. Okay, so that's going to give you 1. Again, the cubed root of 1 is 1 because that's the perfect cubed. Now, I'm going to have to do all these in the calculator because I do not know these by heart. So 2 cubed is 8. So if you take the cubed root of 8, you get 2. 3 cubed is 27. So the cubed root of 27 is 3. Now, I want to take a second real quick. You cannot have a plus or minus answer with these because if you take the negative number and multiply it 3 times, I'm just going to show you what I'm talking about. If you take negative 2 and multiply it by -2 3 times, look at what happens. This becomes positive, but when you multiply it by a negative again, you get -8, which is not 8. So this will not have an answer of plus or minus. Just the square roots will do that. All right, so 4 cubed, get 64. So the cubed root of 64 is going to be 4. 5 cubed is going to be 125. So if you take the cubed root of 125, you're going to get 5. 6 cubed is 216. So the cubed root of 216 is 6. 7 cubed is 343. So if you take 343, the cubed root of that, you get 7. 8 cubed is 512. So the cubed root of 512 is 8. 9 cubed is 729. So the cubed root of 729 is 9. And 10 cubed is 1,000, which is 10. I'm going to